What if a single military vehicle could unleash 40 rockets in under 20 seconds, not aimed at one target, but across an entire battlefield? For much of modern history, warfare has not been decided by precision alone, but by scale, speed, and shock. Few weapons represent that idea more clearly than the BM-21 Grad. Developed during the height of the Cold War, the BM-21 was never meant to be subtle. It was designed to deliver overwhelming firepower in a matter of seconds, shaping the battlefield before opposing forces could even react. Mounted on a rugged military truck and armed with rows of rocket tubes, the Grad transformed rocket artillery from a specialized weapon into a mass-produced system used around the world. Unlike traditional artillery, which fires one round at a time, the BM-21 could saturate wide areas almost instantly. This approach reflected the military thinking of its era, a time when large formations, rapid advances, and decisive firepower defined strategy. In that context, speed mattered more than accuracy, and disruption was often more important than destruction. As Cold War tensions spread across continents, so did the Grad. Its relatively simple design made it easy to operate, maintain, and export. Over time, it appeared in conflicts far beyond the borders of its original designers, becoming one of the most recognizable rocket artillery systems ever built. But the story of the BM-21 is not just about rockets and vehicles. It's about how nations prepare for war, how technology reflects strategic priorities, and how design choices made decades ago continue to influence modern battlefields. Even today, long after the Cold War ended, systems based on the original Grad remain in service, upgraded, modified, and adapted to new realities. So how did this system actually work? What made it so widely adopted? And in an age of drones, satellites, and precision-guided weapons, why does a Cold War-era rocket launcher still matter? To understand the BM-21 Grad is to understand a different philosophy of warfare, one built on mass, momentum, and the belief that sometimes, controlling space matters more than hitting a single point. And that story begins here. When the BM-21 Grad entered service in the early 1960s, the world was living under the constant shadow of the Cold War. Two global power blocks, the Soviet Union and its allies on one side, and NATO on the other, were locked in a struggle that was ideological, political, economic, and military. While open conflict between these superpowers never erupted directly, both sides prepared intensely for the possibility of a large-scale conventional war in Europe or elsewhere. This preparation shaped every aspect of military design and doctrine. Weapons were not built only for limited engagements, but for scenarios involving massive armies, rapid advances, and battles stretching across entire regions. In this environment, artillery was not simply a supporting element, it was central to how wars were expected to be fought. The Soviet Union, in particular, placed enormous emphasis on artillery. This focus was rooted in both historical experience and strategic necessity. During the Second World War, Soviet forces relied heavily on large concentrations of artillery to break enemy defenses and support infantry and armored units. Massed firepower, delivered quickly and in overwhelming volume, became a defining feature of Soviet military thinking. By the late 1950s, however, much of the Soviet Union's rocket artillery inventory was becoming outdated. Earlier systems were often heavy, slow to deploy, and limited in mobility. As warfare evolved, Soviet planners recognized the need for a new generation of artillery systems, ones that could keep pace with fast-moving mechanized forces and deliver firepower on demand. The result was the BM-21 Grad. Officially introduced in 1963, the BM-21 was designed to replace older multiple rocket launcher systems with a more mobile, reliable, and versatile platform. Instead of being mounted on heavy, specialized vehicles, the Grad was built on a rugged military truck chassis. This choice reflected a broader shift in Soviet doctrine. Mobility was becoming just as important as firepower. At the heart of this doctrine was the belief that future wars would be decided quickly. Soviet military planners expected conflicts to be intense, fast-moving, and decisive, with little time for prolonged stalemates. mechanized infantry and armored formations would advance rapidly, supported by artillery that could suppress, disrupt, and disorganize enemy forces ahead of them. In this context, artillery was not merely a defensive tool or a response to enemy fire. It was an offensive weapon, a means of shaping the battlefield before ground forces arrived. The BM-21 Grad was built precisely for this role. Unlike traditional tube artillery, which fires individual shells at specific targets, the Grad was designed to deliver salvos of rockets in rapid succession. 40 launch tubes, arranged in rows, allowed the system to unleash a concentrated burst of fire over a wide area in a matter of seconds. The objective was not pinpoint accuracy, but saturation, overwhelming a designated zone to disrupt enemy units, command structures, and logistics. This approach stood in contrast to the evolving doctrine of NATO forces. While Western militaries also valued artillery, they increasingly emphasized precision, coordination with air power, and smaller, more flexible units. Advances in targeting, communications, and later precision-guided munitions reflected a different philosophy, hitting specific targets with high accuracy rather than flooding an area with fire. The Soviet approach, by comparison, prioritized simplicity, scale, and reliability. Weapons needed to function in harsh conditions, require minimal maintenance, and be operated by conscript forces with limited training time. The BM-21 Grad fit these requirements perfectly. Its design was straightforward. Fewer complex components meant fewer things could fail. Crews could be trained relatively quickly, and the system could operate effectively in extreme cold, heat, mud, or dust. This reliability made it well suited for the vast and varied environments across the Soviet Union and its allied states. Another key factor behind the Grad's development was cost. During the Cold War, the Soviet Union sought to equip not only its own forces but also those of allied nations. The BM-21 was relatively affordable to produce and maintain, making it attractive for widespread deployment. This affordability played a major role in its eventual global spread. But the importance of the BM-21 was not limited to its technical features. It represented a broader strategic mindset, one that viewed firepower as a way to control space and time on the battlefield. By saturating an area quickly, commanders could limit enemy movement, delay responses, and create opportunities for maneuvering forces. This concept of fire superiority was deeply ingrained in Soviet doctrine. The goal was not necessarily to destroy every target outright, but to create conditions where the enemy could no longer operate effectively. Confusion, disruption, and loss of cohesion were just as valuable as physical damage. The Cold War environment reinforced this thinking. Both sides anticipated battles involving large formations and dense concentrations of troops and equipment. In such scenarios, the ability to blanket an area with fire could have a decisive psychological and operational effect. The BM-21 Grad was also a response to lessons learned from earlier conflicts. Previous rocket artillery systems had demonstrated the potential of massed fire but suffered from limitations in range, mobility, or reliability. The Grad sought to address these issues by combining proven rocket technology with a more adaptable platform. By mounting the launcher on a truck, the system gained speed and flexibility. It could move quickly along roads or rough terrain, set up for firing, launch a salvo, and relocate before enemy forces could respond. This shoot-and-scoot capability reduced vulnerability and increased survivability, an important consideration in an era when counter-artillery fire was becoming more effective. From a strategic perspective, the BM-21 fit neatly into the Soviet concept of layered firepower. Rocket artillery, tube artillery, tanks, and infantry were all integrated into a coordinated system designed to apply pressure across multiple levels of the battlefield. The Grad occupied a specific niche within this structure, providing rapid, high-volume fire when and where it was needed. It is also important to understand the symbolic role of systems like the BM-21 during the Cold War. Military hardware was not only about combat effectiveness, it was also a tool of deterrence and influence. The widespread deployment of rocket artillery signaled capability and readiness, reinforcing perceptions of strength both domestically and abroad. As the Cold War progressed, the Grad became a familiar presence in military parades, training exercises, and strategic planning. Its silhouette, a rectangular block of launch tubes atop a truck, became instantly recognizable. Over time, it came to represent an entire category of weapons rather than just a single system. Despite its origins in a specific historical moment, the core ideas behind the BM-21 proved remarkably resilient. The emphasis on simplicity, massed fire, and mobility ensured that the system remained relevant long after its initial introduction. While technology advanced and warfare evolved, the basic principles that shaped the Grad continued to influence artillery design worldwide. In retrospect, the BM-21 Grad can be seen as a product of its time, but also as a reflection of enduring military realities. Wars are shaped not only by technology, but by doctrine, resources, and expectations. The Grad was built to meet the demands of a world preparing for large-scale conflict, and in doing so, it left a lasting mark on military history. Understanding the historical and strategic context behind the BM-21 is essential to understanding why it was built the way it was and why it continues to appear in discussions of modern warfare today. It was not created as a precision instrument, nor was it intended to operate alone. It was designed as part of a broader system, one that valued overwhelming force, rapid action, and the ability to shape the battlefield before the first ground units arrived. This context sets the stage for everything that follows, from the technical design of the system itself to its role in real-world operations and its comparison with other artillery systems around the globe. To understand the BM-21 Grad, it helps to begin with a simple idea: not all artillery is meant to do the same job. While many people imagine artillery as large cannons firing single shells at distant targets, the BM-21 belongs to a different category entirely. It is a multiple launch rocket system, often shortened to MLRS, a class of weapons designed to deliver many rockets in a very short period of time. At its core, the BM-21 Grad is a mobile rocket launcher. It is mounted on a military truck, combining the firepower of rocket artillery with the mobility of a wheeled vehicle. This design allows it to move quickly across roads and rough terrain, deploy with minimal preparation, fire its rockets, and relocate before enemy forces can respond. The most recognizable feature of the BM-21 is its launcher assembly. On the back of the truck sits a rectangular array of 40 launch tubes, arranged in 4 rows of 10. Each tube holds a single rocket. When viewed from behind, the launcher looks almost industrial in its simplicity, a grid of steel tubes pointing skyward at a slight angle. This layout is not accidental. The rectangular grid allows rockets to be fired in carefully timed sequences, spreading their impact across a wide area. Rather than concentrating fire on a single point, the BM-21 is designed to blanket a designated zone, creating what military planners refer to as area coverage. Unlike traditional artillery pieces, such as howitzers or cannons, the BM-21 does not rely on heavy barrels, recoil systems, or complex loading mechanisms. Rockets are self-propelled, meaning they generate their own thrust after launch. This eliminates the need for thick barrels capable of containing explosive pressure, allowing the launcher itself to remain relatively lightweight. This difference has major implications for how the system operates. Traditional tube artillery typically fires one round at a time. After each shot, the crew must load another shell, adjust elevation or direction if needed, and fire again. While modern artillery can fire quickly, it still delivers fire incrementally. The BM-21 Grad works differently. Once the launcher is aimed and prepared, rockets can be fired in rapid succession, often within seconds. A full salvo of 40 rockets can be launched in under half a minute, saturating the target area almost instantly. This sudden concentration of fire is one of the defining characteristics of rocket artillery. The purpose of this approach is not pinpoint accuracy. Individual rockets are not guided toward specific targets. Instead, they follow ballistic trajectories, landing across a designated area according to calculated dispersion patterns. This dispersion is intentional. The goal is to affect everything within that zone rather than a single object or position. On the battlefield, this gives the BM-21 a distinct role. It is primarily used for area denial, disruption, and suppression. By saturating a region with explosive force, the system can limit enemy movement, interrupt communications, and reduce the effectiveness of defensive positions. Even when physical damage is limited, the sudden intensity of a rocket salvo can force opposing units to disperse or halt operations. This psychological effect is an important part of the BM-21's design philosophy. The sound, speed, and volume of a rocket salvo create an overwhelming sensory experience. For military planners, this effect is not incidental, it is a feature. The system is meant to shock, disorient, and pressure enemy forces during critical moments. Another key aspect of the BM-21 is its mobility. Being mounted on a truck allows it to operate in ways that towed artillery cannot. Traditional artillery pieces often require time to emplace, including stabilizing the weapon, setting firing positions, and coordinating logistics. In contrast, the BM-21 can arrive at a firing location, deploy its launcher, fire, and depart relatively quickly. This mobility supports what is commonly known as shoot-and-scoot tactics. After firing a salvo, the launcher can relocate before enemy counter-battery fire, artillery or airstrikes aimed at the launch site can be organized. This increases survivability and makes the system harder to neutralize. The truck-based design also simplifies logistics. Using a standard military vehicle means maintenance, fuel, and parts can often be shared with other vehicles in the same fleet. This reduces the logistical burden and allows the system to be integrated more easily into existing units. From a non-expert perspective, one way to understand the BM-21 is to think of it as a battlefield shaping tool rather than a precision instrument. It is used to prepare the environment for other forces, tanks, infantry, or mechanized units rather than to directly engage specific targets. In many operational concepts, the BM-21 would fire ahead of advancing ground forces, targeting areas where enemy units are expected to be located or moving. The resulting disruption can slow responses, break up formations, and create opportunities for maneuver. This role contrasts sharply with that of traditional artillery in Western military doctrine. NATO forces have historically emphasized accuracy, integration with air power, and the ability to strike specific targets with minimal collateral impact. While Western militaries also use rocket artillery, they tend to place greater emphasis on guided munitions and precise targeting. The BM-21 reflects a different set of priorities. It was designed to be effective even with limited targeting information. Exact coordinates were less important than general areas of enemy concentration. This made the system particularly useful in fast-moving situations where intelligence might be incomplete or rapidly changing. Another important distinction lies in rate of fire versus sustained fire. Traditional artillery can maintain a steady rate of fire over longer periods, firing shells continuously as long as ammunition is available. Rocket artillery, including the BM-21, is more episodic. It delivers intense bursts of fire followed by periods of movement, reloading, or repositioning. Reloading the BM-21 is a more time-consuming process compared to firing. Each rocket must be loaded individually into its tube, often using a separate resupply vehicle. This means the system is not designed to remain in one position and fire continuously. Instead, it excels at delivering sudden, decisive salvos. For non-experts, it's also useful to understand what the BM-21 is not. It is not a precision strike weapon. It is not intended for close support in urban environments where accuracy is critical. And it is not designed to replace all forms of artillery. Rather, it complements other systems by filling a specific niche. The simplicity of the BM-21's design has been one of its greatest strengths. Fewer complex components mean fewer mechanical failures. Crews can be trained relatively quickly, and the system can be operated effectively even in challenging environmental conditions. This reliability has contributed to its widespread adoption around the world. Over time, the basic BM-21 concept has been adapted and modified by many countries. Variants have appeared on different truck chassis, with different electronics, and with rockets of varying ranges. Despite these changes, the fundamental layout, a truck-mounted launcher with a grid of rocket tubes, has remained largely unchanged. This consistency speaks to the effectiveness of the original design. While technology has advanced, the core idea behind the BM-21 remains relevant: deliver rapid, high-volume fire to influence the battlefield at key moments. From a strategic perspective, the BM-21 also illustrates how weapons systems reflect the doctrine of the nations that build them. The emphasis on massed fire, mobility, and simplicity mirrors broader Soviet and later Russian military thinking. It prioritizes systems that can be deployed widely, maintained easily, and used effectively under a wide range of conditions. For American viewers, understanding the BM-21 offers insight into how different military cultures approach the same problem. Where one side may seek precision and technological complexity, another may emphasize robustness and volume. Neither approach is inherently right or wrong, each reflects different assumptions about how wars are likely to be fought. In summary, the BM-21 Grad is a multiple launch rocket system designed to deliver rapid, concentrated fire over a wide area. Mounted on a mobile truck platform, it combines speed, simplicity, and firepower into a single system. Unlike traditional artillery, it trades precision for saturation, focusing on disruption and area control rather than individual targets. This system overview provides the foundation for understanding everything else about the BM-21, from its technical components to its operational use and its enduring presence on modern battlefields. With this high-level understanding in place, we can now take a closer look at how the system works in detail, and why its design choices continue to matter today. One of the BM-21 Grad's greatest strengths is its simplicity. From its vehicle platform to its rockets and operating procedures, the system was designed to be rugged, reliable, and easy to use under a wide range of conditions. This design philosophy reflects the priorities of the era in which it was created, a time when systems needed to function consistently, even with limited infrastructure, harsh weather, and crews with relatively short training cycles. To understand why the Grad proved so enduring, it's important to examine how its main components work together: the vehicle and launcher, the rockets themselves, and the way the system is operated in the field. At the foundation of the BM-21 is its truck chassis. Early versions of the Grad were mounted on a Soviet-built 6x6 military truck, chosen for its off-road capability, durability, and mechanical simplicity. This chassis allowed the system to operate across a wide range of terrain: paved roads, dirt tracks, mud, snow, and uneven ground. Mobility was a key requirement. Soviet planners expected artillery units to move frequently, keeping pace with advancing armored and mechanized formations. A wheeled truck offered several advantages over tracked vehicles: it was faster on roads, required less maintenance, consumed less fuel, and could travel long distances without specialized transport. The launcher assembly is mounted on the rear of the truck. This structure consists of 40 launch tubes arranged in a rectangular grid. Each tube is essentially a steel guide that supports and directs a rocket during launch. Because rockets are self-propelled, the launcher does not need to absorb recoil in the same way as traditional artillery. This reduces mechanical stress and allows for a lighter overall structure. The launcher can be elevated and traversed to aim the rockets toward a target area. In early versions of the BM-21, these adjustments were largely mechanical, relying on hand-operated systems rather than advanced electronics. While this may seem primitive by modern standards, it offered significant advantages in reliability and ease of repair. Minimal electronics meant fewer components that could fail in combat conditions. The system could operate without reliance on complex sensors, computers, or digital networks. This made it well suited for environments where maintenance support was limited or where electronic systems might be vulnerable to interference. The overall construction of the vehicle and launcher emphasized ruggedness over refinement. Components were built to withstand vibration, dust, moisture, and temperature extremes. The result was a system that could remain operational even after prolonged use in challenging conditions. The BM-21 fires 122mm rockets, a caliber that became standard for this class of weapon. Each rocket is a self-contained munition, consisting of a rocket motor, a stabilizing system, and a warhead. After launch, the rocket's motor ignites, propelling it toward the target area. Unlike guided missiles, these rockets do not adjust their flight path once launched. Instead, they follow a ballistic trajectory determined by launch angle, initial velocity, and environmental factors such as wind. Stabilization is typically achieved through fins that deploy after launch, helping to keep the rocket oriented correctly during flight. The rockets used by the BM-21 were designed with different purposes in mind. While specific details vary by variant and era, the general idea was to offer a range of options depending on mission requirements. Some rockets were optimized for area effects, while others focused on specialized roles. Importantly, the system was not limited to a single type of rocket, increasing its flexibility. One of the defining characteristics of BM-21 rockets is their dispersion. Because the rockets are unguided, they do not all land at exactly the same point. Instead, they spread across a designated area according to predictable patterns. This dispersion is not a flaw, it is a feature. By dispersing impacts across a wide zone, the system increases the likelihood of affecting multiple targets within that area. This makes the BM-21 effective against formations, staging areas, supply points, and other broad targets where exact precision is less critical than overall coverage. Range is another important factor. Depending on the rocket type, the BM-21 can engage targets several kilometers away. This standoff distance allows the launcher to operate behind friendly lines while still influencing events at the front. Over time, improved rocket designs extended this range further, but the basic concept remained the same. From a technical standpoint, the rockets balance simplicity and effectiveness. They are relatively easy to manufacture compared to guided munitions, and they can be stored and transported without extreme requirements. This contributes to the system's overall sustainability and widespread adoption. Operating the BM-21 requires a small crew, typically consisting of a driver and several operators responsible for aiming, firing, and reloading the launcher. The exact number can vary depending on unit organization and procedures, but the system was designed to function efficiently with minimal personnel. The firing process begins with positioning the vehicle at a suitable location. This involves selecting terrain that offers both a clear firing arc and a degree of concealment. Once in position, the crew deploys stabilizing supports if needed and prepares the launcher for firing. Aiming the launcher involves adjusting elevation and direction based on firing data. In early versions, this data was often calculated manually or provided by higher-level command units. While less precise than modern digital fire control systems, this approach was effective within the context of area saturation missions. Once the launcher is aimed, the crew can initiate the firing sequence. Rockets may be launched individually or in rapid succession as part of a full salvo. A complete salvo of 40 rockets can be fired in a very short time, delivering a sudden and intense burst of firepower. After firing, the BM-21 does not remain in position. This is where shoot-and-scoot tactics come into play. Because rocket launches create visible signatures such as smoke trails, the firing position can quickly be identified by enemy forces. Remaining stationary would increase the risk of counterfire. To mitigate this risk, crews are trained to relocate immediately after firing. The truck-based design allows the BM-21 to move quickly, often within minutes of completing a salvo. This rapid displacement makes it difficult for opposing forces to target the launcher effectively. Reloading the BM-21 is a more deliberate process. Each rocket must be loaded into its tube, usually with the assistance of a resupply vehicle. While this takes time, it is typically done away from the firing position, further reducing vulnerability. The emphasis on mobility and quick relocation is central to the BM-21's operational concept. Rather than engaging in prolonged duels, the system delivers short, powerful strikes and then withdraws. This hit-and-move approach increases survivability and preserves combat effectiveness over time. The technical characteristics of the BM-21 reflect a consistent design philosophy. Fewer moving parts meant faster training, easier maintenance, and higher reliability. Crews did not need extensive technical expertise to operate the system effectively, and repairs could often be carried out in the field. This simplicity was especially valuable in large-scale forces composed largely of conscripts. Training time could be kept relatively short, allowing units to become operational quickly. At the same time, the system's robustness reduced downtime caused by mechanical failures. Harsh environments were also a major consideration. From freezing winters to dusty plains, the BM-21 was expected to operate reliably under conditions that might challenge more complex systems. Its mechanical focus and limited reliance on electronics made this possible. Another important aspect is scalability. Because the system is relatively inexpensive and easy to maintain, it can be deployed in large numbers. Multiple launchers operating together can create extremely dense fire coverage, amplifying their overall effect. From a technical perspective, the BM-21 does not represent cutting-edge innovation in any single area. Instead, it excels by combining proven technologies into a cohesive, effective system. Its success lies not in sophistication, but in balance, matching capabilities to doctrine and operational needs. The combination of mobility, rapid firing, and simple operation makes the BM-21 difficult to neutralize. By the time enemy forces detect a launch, calculate its origin, and respond, the launcher may already be on the move. This survivability is not accidental. It is built into every aspect of the system's design and operation. The truck chassis allows quick movement, the launcher enables fast salvos, and the operating procedures emphasize immediate relocation. As a result, the BM-21 can remain effective even in contested environments. While it is not invulnerable, its design complicates efforts to suppress or destroy it, especially when deployed as part of a larger artillery force. In technical terms, the BM-21 Grad is a study in purposeful simplicity. Its vehicle platform prioritizes mobility and durability. Its launcher provides rapid, high-volume fire without complex mechanisms. Its rockets deliver area coverage through dispersion rather than guidance. And its operational tactics emphasize speed, relocation, and survivability. Together, these elements form a system that has remained relevant for decades. While newer technologies have introduced greater precision and connectivity, the fundamental advantages of the BM-21 reliability, mobility, and massed firepower continue to make it a significant presence in modern discussions of artillery. This technical foundation sets the stage for understanding how the BM-21 is used in real-world contexts, how it compares to other systems, and why it continues to be adapted and modernized today. Over time, the BM-21 Grad became one of the most widely exported artillery systems in history. Long after its introduction during the Cold War, it spread far beyond the borders of the Soviet Union, appearing in the inventories of dozens of countries across multiple continents. This global presence was not accidental. It was the result of a system that aligned closely with the strategic, economic, and operational needs of many different militaries. To understand the real-world implications of the BM-21, it's important to look beyond the machine itself and focus on what it changed, how commanders planned operations, how battlefields were shaped, and how the presence of such a system influenced decision-making on both sides of a conflict. At a strategic level, the BM-21 Grad reinforced a particular way of thinking about warfare, that controlling space can be just as important as destroying specific targets. Rather than focusing solely on precision strikes, the GRAD made it possible to influence large areas quickly, creating zones where movement became difficult or risky. This capability had a direct impact on planning. Commanders could use rocket artillery to prepare an area before an advance, disrupt enemy concentrations, or limit reinforcement routes. The emphasis was not on eliminating every threat, but on shaping conditions in a way that favored friendly forces. Because a single BM-21 could affect a wide area in seconds, it multiplied the perceived strength of the unit operating it. When deployed as part of a larger formation, multiple launchers could coordinate salvos to cover even broader zones. This concentration of firepower gave artillery a decisive role in operational planning. Importantly, the GRAD did not require the same level of targeting precision as other systems. This meant it could be used effectively even when intelligence was incomplete or rapidly changing, a common reality in large-scale operations. As a result, it became a reliable tool in fluid and uncertain situations. One of the most significant real-world effects of the BM-21 was psychological rather than purely physical. The knowledge that a unit possessed rocket artillery capable of rapid saturation fire could influence enemy behavior before a single rocket was launched. Deterrence does not always rely on use. Often, it relies on the credible possibility of use. The BM-21's ability to deliver sudden, overwhelming salvos made it a powerful deterrent tool. Opposing forces had to account for the risk of rapid area fire when planning movements, staging areas, or defensive positions. This deterrent effect extended beyond the immediate battlefield. In regions where multiple actors possessed BM-21 systems or similar launchers, the balance of power could be influenced simply by who had the ability to saturate space more effectively. In this way, the system became part of broader strategic calculations. For commanders, this meant thinking differently about terrain. Open areas, road networks, and assembly points could no longer be viewed only in terms of physical geography. They also had to be considered in terms of exposure, how vulnerable they might be to sudden rocket fire. The BM-21 GRAD contributed to a shift in how battlefields were conceptualized. Instead of focusing exclusively on fixed lines or individual objectives, commanders increasingly thought in terms of zones, areas that could be controlled, denied, or influenced through firepower. Rocket artillery played a central role in this shift. By delivering fire across wide areas, systems like the GRAD allowed forces to shape the battlefield dynamically. Routes could be disrupted, defensive positions weakened, and enemy units forced to disperse or delay. This approach was particularly effective in fast-moving operations. When forces advanced quickly, traditional artillery might struggle to keep up or redeploy in time. The mobility of the BM-21 allowed it to reposition rapidly, maintaining pressure as the situation evolved. The result was a more fluid battlefield, where control was exerted through timing and coverage rather than static positions. This concept influenced not only Soviet and Allied doctrine, but also how other militaries evaluated the role of rocket artillery in their own forces. The widespread adoption of the BM-21 was driven by several key factors, chief among them affordability. Compared to more complex weapons systems, the GRAD was relatively inexpensive to produce, operate, and maintain. This made it accessible to countries with limited defense budgets. Ease of use was another critical factor. The system did not require highly specialized training or advanced infrastructure. Crews could be trained in a relatively short period of time, and the launcher could operate effectively in environments where maintenance support was minimal. Logistics also played a role. Because the BM-21 was mounted on a standard military truck, it could integrate easily into existing vehicle fleets. Fuel, spare parts, and basic maintenance skills were often already available, reducing the burden of adoption. Additionally, the system's adaptability made it attractive. Over time, different countries mounted GRAD launchers on locally produced trucks, integrated updated communications, or developed their own rocket variants. This flexibility allowed the core design to remain relevant across diverse operational contexts. As a result, the BM-21 became not just a Soviet weapon, but a global one, adapted, copied, and modified to suit a wide range of military doctrines and environments. The presence of BM-21 systems influenced how commanders on both sides of a conflict approached planning and execution. For those operating the system, it provided a tool for rapid response and battlefield shaping. For those facing it, it introduced uncertainty and risk. Enemy forces had to consider the possibility of sudden area fire when choosing routes, timing movements, or concentrating units. This often led to more cautious behavior, dispersion of forces, and changes in tempo. From a defensive perspective, the threat of rocket artillery encouraged the development of countermeasures, including dispersion tactics, hardened positions, and improved detection methods. In this way, the BM-21 indirectly drove innovation and adaptation across military forces. Importantly, these effects occurred even when the system was not actively used. Its mere presence altered calculations, demonstrating how weapons can shape behavior without constant engagement. Despite its influence, the BM-21 Grad was never a standalone solution. Its effectiveness depended on integration with other systems, reconnaissance, command and control, logistics, and maneuver forces. Used in isolation, it offered limited utility. This reality underscores an important point about real-world implications. Weapons do not determine outcomes on their own. They operate within broader systems shaped by doctrine, training, leadership, and resources. The Grad's success stemmed from how well it fit into a particular way of fighting. When employed in alignment with that doctrine, it amplified effectiveness. When misused or unsupported, its impact was far more limited. Over decades of service, the BM-21 Grad left a lasting imprint on military thinking. It demonstrated that simplicity and scale could coexist with effectiveness. It showed that advanced technology was not always necessary to achieve strategic influence. This lesson resonated with many nations, particularly those seeking cost-effective ways to project power or deter adversaries. As a result, the core concepts behind the Grad continued to influence new systems long after its initial introduction. Even as warfare evolves toward greater precision and connectivity, the idea of controlling space through saturation remains relevant in certain contexts. The BM-21 stands as an example of how enduring design principles can shape real-world outcomes across generations. In real-world terms, the BM-21 Grad changed how battlefields were planned, perceived, and contested. Its affordability and ease of use drove global adoption. Its ability to saturate space influenced strategy, deterrence, and operational behavior. And its presence alone often shaped decisions long before any engagement occurred. Rather than being defined solely by its firepower, the Grad's true impact lies in how it altered thinking, encouraging commanders to view the battlefield as a dynamic space shaped by timing, coverage, and pressure. Understanding these implications helps explain why the BM-21 remains a subject of study today. It is not just a piece of military hardware, but a case study in how design, doctrine, and strategy intersect to influence real-world outcomes. When comparing the BM-21 Grad to Western rocket artillery systems, one name inevitably comes up for American audiences: the US M270 Multiple Launch Rocket System, or MLRS. On the surface, both systems appear to fill a similar role. They are mobile rocket launchers designed to deliver significant firepower over long distances. Yet beneath that similarity lies a profound difference in philosophy, doctrine, and technological approach. Understanding these differences helps explain not only how these systems perform, but why they were built the way they were and what they reveal about the military thinking of their creators. The BM-21 Grad and the M270 MLRS were born in different strategic environments. The Grad emerged from the Soviet Union's expectation of large-scale, fast-moving ground wars involving massive formations. The M270, developed decades later by the United States and its NATO partners, reflected a military culture increasingly focused on precision, coordination, and technological integration. At a basic level, the BM-21 emphasizes volume and speed. Its purpose is to deliver a large number of rockets quickly, covering a wide area in a short amount of time. Precision is secondary to coverage. The system is designed to shape the battlefield through saturation. The M270 MLRS, by contrast, emphasizes precision and flexibility. While it is capable of firing multiple rockets, its modern role centers on guided munitions that can strike specific targets with high accuracy. The system is designed to integrate seamlessly with advanced intelligence, surveillance, and reconnaissance networks. These contrasting priorities reflect different assumptions about how wars are fought. One of the clearest distinctions between the BM-21 and the M270 lies in how they approach accuracy. The Grad's rockets are unguided. Once launched, they follow a ballistic path determined by physics rather than onboard guidance. The result is dispersion rockets spread across a target area. This dispersion is intentional. The BM-21 is meant to affect everything within a zone, rather than a specific point. In scenarios involving large troop formations, staging areas, or broad defensive lines, this approach can be effective. It prioritizes disruption over exact targeting. The M270 MLRS, especially in its modern configurations, operates on a very different principle. Its rockets and missiles are often guided, using systems such as GPS and inertial navigation. This allows them to strike precise coordinates, sometimes from significant distances. For American military doctrine, this precision is critical. It supports the ability to engage high-value targets while minimizing unintended effects. It also aligns with broader NATO emphasis on controlled escalation, interoperability, and information-driven warfare. Neither approach is inherently superior. Each is optimized for different strategic contexts and constraints. Doctrine, the way militaries plan and fight wars, plays a central role in shaping weapons systems. The BM-21 reflects Soviet doctrine, which historically emphasized mass, momentum, and redundancy. Systems were expected to function even if communications were disrupted or intelligence was incomplete. In this framework, artillery was a primary tool for breaking enemy cohesion. Rocket artillery like the Grad could be used early in an operation to overwhelm defenses and create openings for maneuver forces. The system did not require perfect information to be effective. NATO doctrine, particularly in the post-Cold War era, evolved toward a more information-centric model. Precision weapons, real-time intelligence, and joint operations became central. The M270 MLRS fits neatly into this model, acting as part of a larger network that includes satellites, drones, aircraft, and command centers. Where the Grad can operate with relatively minimal external support, the M270 thrives in a connected environment. Its effectiveness increases as the quality of information improves. Another key difference lies in industrial capability and priorities. The BM-21 was designed to be produced in large numbers using relatively simple manufacturing processes. Its rockets are less complex and cheaper to produce than guided munitions. This industrial approach allowed the Soviet Union and its allies to field large rocket artillery forces without excessive cost. It also made the system attractive for export, contributing to its global spread. The M270 MLRS, on the other hand, reflects the industrial strengths of the United States and its partners. Advanced electronics, guidance systems, and integration with digital networks require a more sophisticated industrial base. The result is a system that is more expensive per unit but offers capabilities that align with U.S. strategic priorities. This difference highlights an important reality: weapon systems are shaped as much by economics and industry as by battlefield requirements. Both systems demonstrate flexibility, but in different ways. The BM-21's adaptability comes from its simplicity. It can be mounted on different truck platforms, use various rocket types, and operate effectively in diverse environments. Many countries have modified the basic Grad design to suit their own needs. The M270's flexibility comes from modularity and software-driven upgrades. New munitions, improved targeting systems, and enhanced communications can be integrated without redesigning the entire platform. This allows the system to evolve alongside advances in technology. These approaches reflect different paths to longevity. The Grad remains relevant through widespread use and incremental adaptation. The M270 remains relevant through technological upgrades and integration. On the battlefield, these differences translate into distinct operational roles. A BM-21 unit might be tasked with rapidly saturating an area ahead of an advance, creating disruption and limiting enemy response. Its impact is immediate and broad. An M270 unit might be tasked with striking specific command nodes, logistics hubs, or other high-value targets identified through intelligence. Its impact is targeted and precise. In combined operations, these roles can complement each other. Saturation fire can disrupt and shape the environment, while precision strikes can exploit vulnerabilities. This underscores a key point: modern warfare often involves a mix of approaches rather than a single solution. For American viewers, comparing the BM-21 and the M270 offers insight into how military culture influences technology. The U.S. military's emphasis on precision, accountability, and technological edge is reflected in systems like the M270. At the same time, the enduring presence of the BM-21 serves as a reminder that simpler systems can remain effective under the right conditions. Not every conflict allows for perfect information or full technological dominance. In such environments, volume and speed can still play a role. This comparison challenges the assumption that newer or more advanced always means better. Effectiveness depends on context, objectives, and constraints. It's important to emphasize that neither the BM-21 Grad nor the M270 MLRS represents a universally superior solution. Each was designed to meet specific needs and reflects the strategic priorities of its creators. The Grad excels in situations where affordability, simplicity, and rapid area coverage are paramount. The M270 excels where precision, integration, and flexibility are required. Both systems have influenced how militaries around the world think about rocket artillery. Their coexistence highlights the diversity of approaches within modern warfare. In comparing the BM-21 Grad with Western systems like the US M270 MLRS, we see two distinct philosophies at work. One prioritizes saturation and speed, the other precision and integration. These differences are not accidents, they are deliberate choices shaped by doctrine, industry, and strategic outlook. Understanding these contrasts helps explain why both systems continue to exist and evolve. It also underscores a broader lesson: military technology is never just about hardware. It is a reflection of how nations perceive threats, allocate resources, and prepare for the conflicts they believe are most likely. This comparison sets the stage for the final chapter, examining the limitations of the BM-21 and how systems like it may change in the future. Despite its strengths and long service life, the BM-21 Grad is not without limitations. Like all military systems, it reflects the assumptions, technologies, and strategic realities of the time in which it was created. As warfare has evolved, many of the conditions that once favored the Grad have changed, introducing new challenges that older designs must now confront. Understanding these limitations does not diminish the system's historical significance. Instead, it provides a clearer picture of why modernization efforts exist, how rocket artillery is changing, and what the future may hold for systems built on similar principles. One of the most frequently discussed limitations of the BM-21 is accuracy. The Grad was never designed to deliver precision strikes. Its rockets are unguided, relying on ballistic trajectories and predictable dispersion rather than onboard guidance. In earlier eras, this limitation was acceptable, even desirable, because the system's purpose was area coverage rather than point targeting. When enemy forces operated in large formations or relied on fixed infrastructure, saturation fire could be highly effective. However, modern battlefields increasingly reward precision. Smaller, dispersed units, hardened positions, and complex environments reduce the effectiveness of unguided area fire. In these conditions, the inherent dispersion of BM-21 rockets can limit their utility. Accuracy also affects ammunition efficiency. Unguided rockets require larger salvos to achieve the desired effect, increasing logistical demands and exposure during firing. In contrast, guided munitions can achieve similar outcomes with fewer rounds. These accuracy limitations do not make the BM-21 obsolete, but they do restrict the range of scenarios in which it is most effective. As precision becomes more central to modern doctrine, systems like the Grad must adapt or accept a narrower role. Another major challenge facing the BM-21 is the modern sensor environment. When the Grad was first introduced, detecting artillery launch positions was far more difficult. Counterfire often relied on sound ranging, visual observation, or delayed intelligence. Today, the situation is very different. Drones, satellites, radar systems, and networked sensors can detect launches quickly and with increasing accuracy. The visible signatures created by rocket launches, smoke, heat, and movement can be identified and tracked within minutes or even seconds. This development places rocket artillery under greater pressure. Even with shoot-and-scoot tactics, the window between firing and potential counterfire has narrowed. Systems that rely on rapid relocation must now move faster and operate more cautiously to survive. The BM-21's basic design offers limited built-in protection against detection. Early versions lack advanced countermeasures, electronic warfare capabilities, or stealth features. While mobility still provides some survivability, it is no longer sufficient on its own. This vulnerability highlights a broader shift in warfare. Visibility has increased. Actions that once went unnoticed are now rapidly detected, forcing artillery systems to adapt to a more transparent battlefield. The original BM-21 was designed for an era when communications were simpler and less centralized. Fire missions were often planned in advance or coordinated through hierarchical command structures. While effective in its time, this approach can be limiting in modern, fast-paced operations. Today's military systems increasingly rely on real-time data sharing, networked command and control, and integration across domains. Rocket artillery is expected to receive targeting data quickly, adjust fire dynamically, and coordinate closely with other assets. Older BM-21 systems, particularly those without modernization, struggle to meet these expectations. Limited electronics and analog fire control methods reduce responsiveness and flexibility. This can place them at a disadvantage compared to newer systems designed from the ground up for networked warfare. Recognizing these challenges, many operators have pursued modernization rather than replacement. One of the reasons the BM-21 has endured is its adaptability. The core platform, a truck-mounted launcher with multiple rocket tubes, provides a flexible foundation for upgrades. Modernized variants often focus on improving accuracy, survivability, and integration. Enhanced fire control systems, including digital navigation and targeting aids, can reduce dispersion and improve responsiveness. While still unguided in many cases, rockets can be delivered more consistently to intended areas. Mobility improvements are another focus. Newer truck chassis offer better speed, off-road performance, and reliability. Some upgrades include armored cabs to improve crew protection, reflecting lessons learned from modern conflicts. Survivability enhancements may include faster setup and firing procedures, improved camouflage, and integration with electronic warfare systems. These changes aim to reduce detection and increase the chances of relocating before counterfire arrives. Importantly, these upgrades do not fundamentally change the BM-21's role. They refine it. The system remains focused on delivering rapid, high-volume fire, but with greater awareness of modern threats. One of the most significant trends in rocket artillery is the gradual introduction of guidance technologies. While the original Grad rockets are unguided, some modern developments aim to reduce dispersion through improved stabilization or limited guidance features. These advancements blur the line between traditional rocket artillery and precision systems. By improving accuracy without fully abandoning the saturation concept, upgraded rockets attempt to balance old and new philosophies. However, guided rockets come with trade-offs. They are more expensive, more complex, and require higher quality targeting data. This raises questions about cost-effectiveness, particularly for forces that value simplicity and volume. As a result, many operators pursue a mixed approach, retaining unguided rockets for area missions while introducing more accurate options for specific scenarios. Looking ahead, the future of rocket artillery is likely to be defined by diversity rather than uniformity. No single approach will dominate all contexts. Instead, different systems will coexist, each optimized for particular roles and constraints. Precision-guided systems will continue to expand, driven by advances in sensors, navigation, and data processing. These systems offer clear advantages in controlled environments with strong information support. At the same time, simpler systems inspired by the BM-21's philosophy are unlikely to disappear. In environments where cost, scale, or infrastructure limit the use of advanced technology, saturation-based systems still offer value. The key trend is integration. Future rocket artillery will increasingly operate as part of broader networks, coordinating with drones, satellites, and other assets. Even simpler systems may benefit from external targeting data and shared situational awareness. The enduring lesson of the BM-21 Grad is that military technology cannot be evaluated in isolation. Effectiveness depends on doctrine, resources, training, and context. A system that performs well in one environment may struggle in another. The Grad was successful not because it was technologically advanced, but because it aligned closely with the doctrine and realities of its operators. It delivered what was needed, at a scale and cost that made sense. Modernization efforts reflect the same principle. Upgrades are not about turning the BM-21 into something entirely different, but about preserving its relevance within changing conditions. As the BM-21 enters the later stages of its service life, it occupies a unique place in military history. It is both a product of the Cold War and a participant in modern conflicts. Its limitations are real, but so is its adaptability. The system's continued presence reminds us that progress in warfare is not always linear. New technologies do not instantly replace older ones. Instead, they coexist, overlap, and influence each other. In this sense, the BM-21 Grad is less a relic than a reference point, a way to understand how military thinking evolves and how design choices echo across decades. Despite its strengths, the BM-21 is not without limitations. In an era defined by drones, satellites, and precision counterfire, older systems face challenges that their designers could not have fully anticipated. Modern upgrades attempt to improve accuracy, mobility, and survivability, but the core concept remains unchanged. The Grad still emphasizes speed, volume, and area control over pinpoint precision. Ultimately, the BM-21 is a reminder that military technology is not just about innovation. It is about doctrine, resources, and the realities of war. Understanding why it was built, how it was used, and how it continues to adapt offers insight not only into one weapon system, but into the broader dynamics that shape military history. And with that understanding, we can better appreciate why systems like the BM-21 continue to matter, not as symbols of power, but as lessons in how strategy, technology, and human decision-making intersect on the battlefield. The BM-21 Grad is not famous because it is perfect. It is famous because it works within the philosophy it was designed for. Built for speed, scale, and simplicity, it reflects a way of thinking about warfare shaped by history, resources, and strategic priorities. Studying systems like the Grad isn't about celebrating technology, but understanding choices, why certain designs endure, and how doctrine shapes the tools nations rely on. In the end, the BM-21 reminds us that military power is not just about innovation, but about context, adaptability, and reality itself.